All right, so hi everybody. I am super excited to talk with you all about marine plastics for this week's Deep Dives with Terranaut Club. As I mentioned before, I'm Jackie Saturno and I study plastic pollution as part of my master's at the Marine Institute at Memorial University of Newfoundland. And what was amazing about working at the Marine Institute is that everyone that I was working with all studied fishing gear and different types of ways that they could try to make it more sustainable. And my project was looking at how it generates microplastics. Although, yes, the microplastics I was found as my results, I also found some more interesting things that were a bit of a curveball, and I'll get into those in a little bit. But before doing anything related to marine plastics, because I'm originally from Toronto, there's no ocean in sight. So I've actually been working mainly on freshwater systems, notably Atlantic salmon. Love working in aquatic systems, and was really a good transition into marine, I think. So I ended up moving to Newfoundland actually before a position that I got at the university as a research assistant for a PhD student that I was working for. And so it was a wonderful opportunity to move out east for the first time and see something different. And for that summer, I worked with Atlantic salmon again, so freshwater systems, but this time we were able to work on a study about telemetry and understanding the migration patterns of Atlantic salmon as they enter the ocean from river systems, and also looking at their diet within this particular river system as well. So doing all sorts of different really cool analysis with that. And although we were looking at food, and their diet, I also started to wonder a bit about contamination, because although it looks very pristine in this shot and its environment, there were times where I would notice some debris that was intentionally or unintentionally leaking into the river system, and started to wonder a bit more about the impacts of pollution from debris. And of course, reading more into it, I had found a lot of different information about plastic ingestion and animals that were affected by smaller plastic particles that weren't just entanglement by ropes or whales being tangled in nets, and noticed that this was a bigger problem than I had anticipated. And plastic pollution was starting to become more of a hot topic issue. And so there were so many resources about, different types of animals, including birds and fish, and that were being affected by this issue. So I started to think about the salmon that I was working with, and if they were eating any plastics within the river system. There are so many of them, and I can only imagine if what they were ingesting. And the lab that I was working with was, luckily I was able to ask if I could use their samples, because they didn't have any use for the guts and the stomachs and the intestines. They were literally just going to throw those away, and I thought I would start my own project. And so they gave me the samples for all of the fish that they didn't need anymore. And I joined the Civic Laboratory of Environmental Action Research, which specializes in doing marine plastic pollution with using citizen science methods. So everything that I was able to do, it can all be replicated by non-scientists. So if anyone's interested, you can go on their website, and they're also known as CLEAR. And they have all sorts of accessible science methods to look for your, look for plastic pollution in your own backyard and with, items around the house. So for this particular project, I simply had to just cut open the fish guts and see what was inside, and using 2 sieves to collect anything that came out. Crazy enough, the fish actually were all clean. So that was good news for anglers on that. But I was still really interested in this project and wanted to pursue it as part of a master's project. And of course, in Newfoundland, fishing is a very important industry, and fishing gear is always used. So it came to no surprise that we were finding all these different types of threads that we weren't really sure what they were at first, because they could, they easily look like algae, especially when they're intertwined into rocks. They really become a part of the environment. But up a closer look, we noticed that they were plastic based on its structure, and were actually coming from fishing ropes and fishing gear. And just to give a little bit of a background on fishing gear, they never used to be made out of synthetic fibers. Originally, they were made from natural fibers, notably cotton, and they made the transition in the 1960s to synthetic when this type of gear was being introduced as a cheaper option for fishers, as a more durable option, and it became a miracle material at that point because it was significantly better than using natural fibers, and increased catch efficiency, and overall was great and had absolutely no problems until there were. So of course, because they are durable, they have a lot of implications that have negative side effects on the environment, of course, with entanglement and ingestion, and even with smothering, with netting landing in the benthic environment and hurting any organisms that's underneath it. But with entanglement ingestion, that definitely can lead to mortality if it cuts open the fish from the inside and does irreversible damage. So it can be quite harmful in that respect. But it even goes down even further because although they aren't biodegradable, they can't dissolve into the environment, they do have the ability to break down into smaller particles. They don't go away, they just get really smaller that becomes harder to detect and puts other animals at risk of ingesting it, like plankton, which has been known to ingest microplastics and even smaller plastics like nanoplastics. So as most notably been discussed, microplastics are anything that's smaller than 5 millimeters. But we also have things that, plastics that range a little bit bigger, like mesoplastics, which are 5 to 20 millimeters, and even macroplastics, which are greater than 20 millimeters. So a large range of animals that can be affected by this. So the thing about microplastics is that because they are smaller than a grain of rice, they are very difficult, if even possible, to recover. So once it's in the environment, that's pretty much it. It's very, very difficult to recover that type of plastic. And because it is so small, you can't even really tell where it originated from to understand how we can stop this from happening. You can do your best to do some detective work with trying to understand what kind of plastic it is, what kind of structure it is. It becomes very, very difficult, especially when it gets to this stage. So the most effective measure is to work with what you can. And in this particular instance, going back to the threads, although it's been ripped up into shreds, it's a lot more easier to identify it from coming from ropes. And with that, any effects that come with it, which lead to animals ingesting it, such as Atlantic Cod. And these were from 2 previous studies that were done by Clear, where they had cut open their stomachs and found these types of threads that are suspiciously looking like they came from ropes based on its structure. And other studies around the world that have found very similar structures as well, pinpointing to fishing gear. Even just identifying it through ropes and knowing how easily it can fray off, it becomes more of a problem where it's not just about ropes that are lost out at sea, but even just gear that is used on a day-to-day basis, how easily it can just fragment. And so it kind of begs the question, should we also be looking at fishing gear that is used on a day-to-day basis and not just gear that gets lost out at sea? So I wanted to see the, all of this happen in action. So I applied for a National Geographic grant to fund this project, to go out to an island called Fogo Island, if you've ever heard of it. It's a smaller island off the coast of Newfoundland. And what's wonderful about this place is that everyone and anyone breathes fishing. If someone's not a fisherman, they know someone who's a fisherman, and which is no different than the rest of Newfoundland. But what I really thought was interesting about this place is that they really honed in on sustainable fishing and trying to adapt what their current methods could use improvement on, and also plastic pollution. They were one of the first communities to have the plastic bag ban, which is sometimes unheard of in small communities, to be the first of that. So that was a great place to do this type of work. And so we were invited to join on with the fishers through the Shorefast Foundation. They were our partnered organization, and we joined them on the fishing boats and assisted them with their work. So if they needed help with collecting fish, we would help them with that. And then we would literally just stand outside with empty plastic bags and trick or treat for fish guts. They normally would just throw them overboard and had no use for them, so that they would just give it to us and we would freeze them later to dissect. So we collected about 200 fish guts over the span of 3 days. So it was a good smell. Also, just to show how hospitable the Newfoundlanders were on Fogo Island, one of the fishers had converted his stage into a wet lab, which was wonderful to be able to do some dissection work right on, like during field work, and do that, like, you know, with running water and a sink that he set up for us, which was unexpected and it completely blew us away. So just to go through what we did, similarly with the salmon guts, we unthawed them, we put them on sieves that would able to catch all the bigger contents on top, and then the smaller contents would just fall right through. And as you can see, it's a very tedious process. We're siphoning through all the organic material and looking for anything that's like man-made or anthropogenic that looks very suspicious. And then we would take it and bring it back to the lab for further analysis to confirm if it was polymer or not. And this was the grand surprise. So we were going in to see if we could find any fishing gear related microplastics, and I went in and found an entire bait bag twice on 2 different occasions. As you can see in the image, in the C image, I had cleaned them all up and opened them up, and they were perfectly intact, that you could honestly use them again. So that was a very interesting find that was not expected. And then of course we found that pesky thread again, that was also identified. So with the bait bags, the interesting thing about how they work is, if you're not familiar with them, is that they essentially are a very important aspect of the traps that are used to catch the cod. They hold all the bait, and then they create this kind of plume phenomenon where they attract the fish into the trap. So the fishermen would tie the bait bags inside the trap, and the codfish would just swim right into the cod pots. And in this case, they ate them whole. So they almost worked too well. And whenever I think about the bait bags, it always brings me back to these 2 images. So as I mentioned before, the cod guts normally get tossed overboard because they're not needed for the processing part. And although the cod meat itself is sold in the co-op, the cod guts are tossed overboard and are normally picked at and eaten by the seagulls or any other fish that gets a chance to ingest it, as well as any sort of plastic or contaminant that's a part of those cod guts, unfortunately. So it almost becomes a vicious cycle where you're reintroducing the plastics back into the environment after removing it. So it's one of those unfortunate things that happens. But the interesting thing about the bait bags that we were able to work with is that we know exactly where they're coming from. And then this is a solution that we can actively try to work towards by making simple gear designs, making sure that those bait bags don't fall off, and not just simply tying them on. So it became a situation where we could actively make a difference with what we were able to find. Otherwise, it would have been a much lower ingestion rate. Would have been much closer to 0 if it wasn't for that thread. So, but that begs the question, where did that thread come from? And how did it come off so easily on these abrasive resistant ropes that we all come to love? So these are the 4 different types of commonly used ropes that the fishing industry uses that I decided to test to see how easily it takes to break them apart. And I did it using a method where we decided to recreate the benthic environment. So in a setting where ropes and gears are in the environment, an abrasive contact would probably be the benthic environment with its rocky surfaces and whatnot. So I created a board essentially with rocks and sand glued onto it, flipped it upside down and attached it to a weight that was then put inside this green tank filled with salt water to kind of recreate that benthic environment, and then had a rope that was attached to a cable hoist going through underneath the seabed and attached to a pulley system to hold it in place. And the idea was that it would rub back and forth and then generate plastics into the water environment for me to collect later. So I do have a video, and fingers crossed that it works. That was the weight that holds it taut, and it feeds through this pulley system up there, which then connects to the ropes that is snakes underneath the seabed, and then comes up again to the cable hoist. And that's essentially how it is set up. And then how it's operated, I apologize for the loudness, but it rubs back and forth on its own, the cable hoist definitely. So luckily it's not me just like flicking a switch back and forth. It's all automated using a Python code to just do its thing. And then afterwards I would go in and collect all the plastics that were floating around in the water. And then again with the side view of the entire setup, just to get an idea of what it looks like in all its glory. And interestingly enough, all the ropes were fragmenting within the first 5 minutes with very little amount of weight to really put onto it. So that was actually quite a bit of a surprise for me and my supervisor. We thought that maybe it might take, you know, at least a couple hours to get some sort of results because they're really, really strong ropes. We didn't anticipate within the first 5 minutes that it would start to shed a lot of fragments from these brand new ropes. And just to get an idea what would happen after 2 hours, this is how much plastics that we would gather, and get an idea of how much goes into the environment with simple abrasion. And the types of sizes that we gathered. So again, it was important for us to get the types of sizes of plastics to get an idea of what kind of organisms in the environment could be affected. Especially with microplastics, mussels and mussel farming is something that's vulnerable to this. So it really put in perspective of like what can go into the environment after abrasion. And so just to do a little activity with you all, because fishing gear is a very common thing that we would find on beach combing surveys, there were also some very interesting things that we found that may not surprise you, it may surprise you. So I thought maybe we could play like a little small activity where you could probably write in the chat what you think this particular item is. If you were like me in Toronto 5 years ago, I probably wouldn't know what this was, but since most of you guys are in the Atlantic region, I think you guys will be able to do this pretty easily. But does anyone have any idea what this black mass is, this round thing? Sure. I gave it away. What was the chat? But yeah, that's a buoy, yeah. So that was pretty good. This one's a lot trickier, obviously, because it's not very easy to determine what it is, but it's a very common thing that you would normally find. And also it does help contain heat of a particular beverage. Does anyone have any idea what this could be? It's a common thing for Tim Hortons. Okay, I'll give this one away. It's a lid. Oh yeah, nice. Yeah. So these pesky things, unfortunately, we find quite a bit. So this one's going to be a little bit tricky. Unless you're parched on a really hot day, it is a container. Perfect for lunch if you were a kid like me. Does anyone have any idea what this is? Yep, it's Kool-Aid. Good job. All right, this one is a bit peculiar, but you might get it based on its unique shape, but a strange thing to find on a beach. Nice, yeah, spray bottle lid. You guys are on it. All right, and so these two are identical, so they're the same thing. Any guesses what this one might be, right off the top of your head? It's also a type of fishing gear too, if that helps. So the two small buoys. So yeah, different kinds. And then the last one is a very strange thing, probably one of the strangest things I've ever found. Definitely something you wouldn't find on a beach. Pretty close, yeah. A childless head doll. So you never know what you're gonna find. Very creepy, absolutely. There have been worse things, but yeah. So that actually leads us to something that I think you all can really like take a part in, which is called the Marine Debris Tracker app. It's this wonderful app that all of us plastic pollution scientists use, especially when we're doing monitoring. And this is a great way for anybody who wants to help with monitoring with plastic pollution and help with the problem. But don't like if you want to do more than just doing beach cleanups, this is a perfect tool to help with also doing data collection at the same time. So you're cleaning up the environment, but also collecting some real data that people can actually use. So how it works essentially is that you find the item that you want to log in, and it has a list of items, in this particular case, a plastic bag, and then you just literally log it in, and it will automatically give you a GPS tracker that you could then see in a map to see all the different types of debris that you had found. And it becomes very useful data that's open source to scientists who want to know different parts of the world, what kind of debris is being found. And if like there's a common piece of debris that's being leaked into the environment that needs better regulation. If you're finding a lot of plastic bags in a particular area, then maybe they need to have some plastic bag bans. So that's just one example. But in this particular case, where I'm, me and my partner, who is also a plastic pollution researcher, we're normally doing some field work right now. And the both of us were talking during this whole COVID pandemic is what can we do that, still is data collection, but, we're still respecting not traveling and doing our part to self-isolate. And then we realized that the answer was actually simple, a lot more simpler than we thought. We just thought that we should just work within our backyard and use the Marine Tracker app and collect data that's, can be put to good use. So something that we've really noticed is that there's been a lot of personal protective equipment, those PPE, being littered all around Toronto. These are the particular areas that we had sampled the past like almost 2 months now, finding face masks and gloves and a new type of debris that we've never really seen before. So this is kind of like a new era with plastic pollution in terms of how COVID is interacting with that. But of course, like, don't want to encourage anybody to go and collect this type of, debris. We are like, professionals with this. So it's a biohazard material after all. So if you are interested in doing the Marine Debris Tracker, we really encourage, to maybe even wait till the pandemic's over, or if you're in an area that's safe that you're able to do it with social distancing. We definitely encourage, to go and do your own citizen science and contribute some really cool data. And on top of that as well is, reducing as much of plastic that you possibly can with your disposables. Try not to do as, choose disposables, but using reusables and all the good stuff. So yeah, that's the end of my presentation.
What's the app called?
So it's called the Marine Debris Tracker app. So when you look it up on your phone, it'll have like an icon of a turtle. So even though it says marine debris, it could be used for, even just in your park or neighborhood. That was kind of like their idea before, but then they decided everyone can use it, not just coastal. So, yeah.
Cool. So if people use the app and, record different plastics and pollutions that are around their their home, you know, in their yard, their parks, their nearby beaches. Is that information, so that information gets turned into data that scientists can use to learn more?
Yeah, so it just becomes a data point in the app where you can see the GPS location and what type of debris it is too, and you can even post a picture of it as well if you want to. And it's all open source, so if I wanted to like log in and see, you know, where in the world, like, you know, someone had logged it in, their data, I can just like zoom in and find it, and it's, you know, it's also download it as well. So it's yeah, it's pretty cool.
That island, I can't remember what you said it was called, but you said that they were doing like sustainable fishing things. What were some of the things they were doing that made
Yeah,
it less wasteful?
the island is called Fogo Island, and my supervisor had worked out there in the past where they were trying to implement cod pots, which is a different method of catching cod. So normally they use gill nets, which can be a little bit harmful on the fish because it catches like smaller fish that aren't ready to be caught. It kind of tears up their flesh, so they're all mangled, and it's not a very ethical way to do it. And also, well, there's a lot of bycatch that happens as well. Whereas the cod pots, if there is bycatch, they're all caught alive, and so they're brought to their surface, and then they can just be brought back into the environment. And even if like there are cod that are caught that are too young still, then they can be returned back as well. So that's kind of like their implementation of trying to be a little bit more sustainable. And also diversifying their catch as well. I think like when the cod population started to dwindle a bit, they started to diversify and not put too much pressure on the, you know, just catching cod.
What does that mean to be a Nat Geo explorer, and how did you do that?
It's an incredible honor, of course, but also a lot of pressure to, like, you know, making sure that you communicate your science to the best of your ability to everybody. So one of the best parts about Nat Geo is that they're not just an agency that will fund and then they'll just disappear. They really help with professional development. And one of the things that they were able to provide was a science communication workshop down at DC that I got the opportunity to attend. And that was a, you know, life-changing experience because I got to learn all sorts of things about like videography and photography and just bettering public speaking. Public speaking was never really my forte before. I had to really hone in on it, and you know, sometimes I wanted to improve it even more. But 5 years ago, if you asked me, it's probably something I would probably avoid at all costs. And I really feel like they helped hone that in with really encouraging their scientists to be a little bit more well-rounded. And so that's really important to me is, you know, what good is your science if no one knows anything about it? So accepting that grant was, you know, a responsibility that I wasn't going to be, you know, something I hold onto myself, but something I have to share with everybody else.